work on Stokes theorem version 2. And basically it says if you want to find this particular line integral, f ds, you can turn it into a double integral. Basically this guy here, dA. And F is your vector field, P, Q, and R. D is the two-dimensional region that you would get if you took the curve and dropped it onto the XY plane. So imagine projecting it onto the floor, you'd see a region of space called D. This fella here will be dx, dy. If you use polar, because the thing on the floor is connected to a circle, then you'll use dr, dr, d theta. And the guy that's called G here, that is the surface that this thing came from. So I'll do another picture because I don't want to mess this up. But there's a lot of different things going on here. Can you imagine you have a surface? Right, so that's meant to be a 3D surface. Do you make 3D look 3D when it's 2D? There. Does that look more or less like a surface? Who cares, right? It's a surface, right? C is going around that surface. Actually, I should go around anti-clockwise if I want to get the right orientation. That's C. Closed loop. C must be a closed loop. Sometimes they put a little circle around it. Sometimes they don't, but it's a closed loop anyway. D is what you would get if you projected this thing onto the floor. And can we just pretend that it looks like that? So D is the shadow of the outside of C hitting the floor, right? It's the shadow of the surface. It's another way of looking at it. And G is the equation of that surface. So Z equals G of XY. So you're going to get as many questions as I can using this version of the formula. So we're going to be asked in every question to find this line integral. The vector field in question 7 is this. The boundary is of this plane in the first octant. So I am going to find what D looks like. Since I'm in the first octant, can I just isolate myself to those two axes? If you take this plane and you project the first octant onto the floor, you're basically making Z0. So what you're getting is 3x plus 2y equals 1. Now, if you find, right, if you make y0, you'll get x as a third. And if you make x0, you get y equals a half. Maybe not the prettiest numbers in the world, but this is D, right? We need to know who D is, right? So basically that's a plane in the first octant hitting the floor. And it hits the floor when Z equals 0. So that's where that came from. This line here is basically just, what's that? 1 take away 3x divided by 2. So it's a half take away 3 upon 2x. Are you comfortable with me just rearranging that to get this equation? But I think we are almost ready. The x's are going to go from 0 to a third. And the y's are going to go from 0 to that straight line. And that straight line happens to be 1/2 take away 3 upon 2x. Are we good? Now I need to use this equation to get g of x. So z equals 1 take away 3x take away 2y. So we now know who g is. So that's that bit then. And based on the fact that these limits of integration are quite linear, I'm going to be doing the dx dy one. So I should be able to put all those pieces together. So the line integral the guy we're trying to find, is going to be the double integral of d. So that's going to go from x equals 0 to x equals 1/3. It's going to do y equals 0 to y equals 1/2, take away 3/2x, brackets. Negative p this guy, negative q this guy, plus r this guy. So there's a lot of moving parts here to keep track of. There's p, q, and r. So it's going to be -1, that's p, times dg by dx. If you differentiate this guy with respect to x, you get -3. So that's this one. Take away, q is all of this, times dg by dy. If you differentiate this guy with respect to y, you get -2, so -2 goes here. Plus r. R is xy, take away the square root of z, and then I can only have enough room for dA here. So it's going to be the integral from 0 to 1/3, the integral from 0 to 1/2, take away 3/2x. That guy gets you 3. Oh God, that guy gets you 2. 2 negatives make a plus. So that gets me 2x plus 2yz. That's an xy, take away the square root of z. And I'm going to have a dy dx going on. And if any z's are left over, then I need to replace them by something, don't I? So what do I need to replace the z's by? Well, I need to replace them by this fella here. Do you see the 1 minus? Okay. So this z is going to be 1 take away 3x, take away 2y, plus an xy, take away the square root of 1, take away 3x, take away 2y. Okay, I've got 3, I have 2x, I have 2y, I have -6xy, I have -4y squared, I have an xy, and I have that guy. Yeah. Okay, we're done. I know that is extremely horrible looking, but can't you differentiate it with respect to x, or integrate it, I should say, with x's and y's? It's not going to be pretty, but you'll be able to do it. And according, well, I actually haven't written down what the answer is here. Could be anything, but it's doable. So I'm dotting it. That's going to take you a fair chunk of time. The answer is 42. It could well be. It's an answer to many things in the universe, so why not this question? That is our first example. This is number 8. Here's our vector field. C, right, this fella here, is the boundary of this guy in the first octant. So I'm going to create my XY thing, because I need to know what D is. And D is basically that guy when he hits the floor. Now, when that guy hits the floor, isn't Z going to be 0? Right? When this expression hits the floor, Z is 0. So we are going to be looking at what does that region look like on the floor. Well, if you make that 0, you get this. And if you rearrange this, we get an old friend. You remember that guy, x squared plus y squared equals 1? It's a circle. Now, very often, wouldn't it be the whole circle? But in this question, it's the first octant. Doesn't the first octant transfer just into the first quadrant when you hit the floor? And so we are looking for a quarter of a circle whose radius is 1. In this case, then, wouldn't it make more sense to do the polar version? Shush, that's my 2 dogs. The radius is 1. Okay, be careful here. What will theta be?
0 to pi halves.
Agreed. Right. Okay. Now, I think I mentioned it yesterday that orientation is important. So we're assuming that the thing is in positive orientation, in which case this will do. If the orientation is downwards or negative orientation, will you just stick a negative in front of this to get the answer? So if your answer is 42 and it doesn't work, try negative 42. It could just be an orientation issue. And that's easy in homework, and it's very easy in the final, right? Because I'll just make sure everything's positive, so you don't need to worry about negative orientation, right? Now, we should be able to get some other pieces. That guy there is our G. So we now know that guy, right? We need it for this bit. We've got P, we've got Q, and we've got R, right? I think we've got everything ready to go. Got all the pieces in all the ducks in a row. So the line integral, that's this guy, is equal to the integral from r equals 0 to r equals 1, the integral from theta equals 0 to theta equals pi upon 2, negative p, so negative xy, and then you differentiate this guy with respect to x, and you get another negative 2x, okay? Minus q, which is this guy, times dg by dy, which gets me another 2y. Add r, and r is zx. And right now, I'm just going to say r d theta dr, right? So r is 0, r is 1, theta equals 0, and it's pi upon 2. I'm going to multiply all this out and then tidy up a little bit. That times that is positive, so I believe you get 2x squared y. That times that, is that a 2? It is a 2.
You forgot to substitute.
Okay.
You forgot to substitute the z.
I haven't substituted the z. You're right, the z. I will do that. If you multiply these together, you get positive 2, I guess zy squared. And then you get a zx. Then you've got the r d theta dr guy. Now you could probably do a couple of things at once. I'm just not comfortable skipping too many lines. So 2x squared y will be fine. The z is going to be turned into that guy, because that guy's z. Don't know if you can point out that that guy is z. Z is this guy times an x. I don't have them. It's just lengthy algebra. It's not, I don't think this is hard, it's just messy. So I got this fella, I got a 2, I take away 2x squared, take away 2y squared. Oh, times a y squared. I'll keep it that way. I'm rewriting this line. I just saw something I could do that would make my life easier. Couldn't have called that 1 take away r squared. Right. 1 minus x squared minus y squared is that guy. So pretend I didn't do that line. It's going to be 2x squared y plus 2 lots of that guy, y squared, plus that guy, with an R, call it DA. Okay, I'm kind of running out of room here. Won't I turn all the X's into R cos theirs? Won't I turn all the Y's into R sin theirs? And this entire horrible mess, won't it just turn into a big expression with R's and sines and cosines, and hopefully some nice things cancelling and simplifying, and off you go. They are not pretty questions, right? If I knew this one was going to be that ugly, do you know, I would have just made up my own. One of the reasons I like to use theirs is that at least sometimes don't they get a nice number like 2 at the end, and you're kind of amazed that it came out that way. But evidently even they can't make questions with Stokes' theorem that come out nice, right?
I think
so
you missed another x squared plus y squared, and that
somewhere
might
else,
create-
that might make it prettier. Yeah,
I think
I'm
it
not.
would've-
Yeah, so I should take it back that they do questions that come out nicer. But that's as far as I'm going with that one. I don't want that one yet. I got this one set up first. It's another first octant guy. They seem to like first octants a lot, so I'm keeping on that theme. This is question 10. So if you want to take an expression like this, 8x plus y plus 8z equals 8, and you want to see what does the D look like, right? The projection of that surface and its edge onto the floor, you basically make Z 0. And if you rearrange that, you get that. And so I have a straight line that basically looks like this. And the equation of this line is this guy. And so my limits of integration are going to be x equals 0 to 1. Are you comfortable about where that 1 came from? Right, 8 take away 8x when is it 0? Is it 0 when x is 1? Right, that's where that came from. And then the y's are from 0 to that guy. Okay, we got that bit done. So box around it to remind me who that is. If you take the equation, this fella here, and you rearrange it to be z equals, that will get you the g of x that we want. So it's going to be 8, take away 8x, take away y, divide everybody by 8, and you get that, and that fella is our g. So let's see if we've got all the pieces. Got my vector field, I've got my range for x's and y's, and I've got my g of xy. So this guy, and this guy, we're good to go. We're being asked to find the value of this line integral. It is going to be from x equals 0 to x equals 1, from y equals 0 to y equals 8, take away 8x. And this is P, this is Q, this is R. So we are going to have e to the negative x times, negative e to the negative x times the derivative of this guy here with respect to x, which is negative 1. Then we're going to take away this fella, who is e to the x, times this guy, dy. So that's going to be negative 1/8. Plus r, and r is just e to the z, and z is 1 take away x, take away 1/8 y, and we can do a dy dx on that. So tidy it up just a little bit. X equals 0 to 1, y equals 0 to 8, take away 8x. That's plus e to the x, that's plus an 8, so that's 9/8 e to the x.
Aren't e to the negative x and e to the x two different numbers?
They are. Have I written?
I mean, trust me, I love the 9.
I like the 9/8. Well,
But with our, isn't it p says e to the negative? Oh
I
yeah,
am
it's
now-
fine.
I
Just
now
go
fixed
back
it.
and change it.
Yeah. They randomize bits and pieces of these questions, so there might be a randomization where that was negative x. And that's-
I don't know if it should be 9/8 e to the x because you have negative e to the negative x. And negative e to the x. So.
Yeah, so now I've got two of them, they're the same. I just changed the question so I could add them and get 9/8. I wanted something to be nice, right? So I've got that. This is integratable. It's downright ugly, but it is doable. So I'll do one version of it. If you integrate this with respect to y, which we are going to do first, you get that guy. If you integrate this, you get e to the 1 minus x minus 1/8 y. And since you're doing it with respect to y, this guy is negative an 1/8. When you integrate, if it's 2, don't you get a half? If it's 4x, you get a quarter, right? If it's negative an 1/8, are you happy with negative 1/8? 1 over negative 1/8 being negative 8. And now we can do the 0 to there. So it's going to be the integral from 0 to 1 of 9/8 e to the negative x times that ugly thing minus 8 e to the 1 minus x. And if you do an 1/8 of that, you get take away a 1 minus an x. And that's one term. Then you subtract a nothing and you plug in 0 here, you get negative e8 to the 1 minus x. So I have, well, multiply that out, you get 9 of these guys. Multiply that out, you get negative 9x e to the negative x. This guy here, negative 1, cancels that. Oh, you get e to the 0. Would you believe it? You'd get, let's check that. Whoa, that's cool. You basically get e to the 0, which is 8. Take away that is plus that fella. Now, barring some arithmetic algebra mistakes, that's the next guy. The only one of them that you should really have trouble with would be this middle term here. How do you integrate a 9x e to the negative x? In Calc 2, how would you integrate that guy?
Integration by parts.
Yeah, and you'd make this f and you'd make this g and you'd do it. I got a guy called question 9, which I'm not going to do because he will take forever and a day and I will just kill him from your homework. I'm not worried about killing him because yesterday, didn't we do a similar one where you had to find the shape? I can't remember. It was x plus y plus z equals 8. Remember the one that looked like that? This is just another one of those. So I don't feel bad about killing that one. So question 9 will disappear. Actually, a little note to self. Number 9, math 264. Yep. Okay. And that'll give me enough time then to move on to really the last group of questions. where am I going with this? I've lost my thought process. Where's my last question we just did? Is it 10? No. 10 it is. Right, in question 10, our vector field is x to the 4, negative x cubed z squared, and 4x y squared z. And our surface, they're describing it as S, is basically x squared plus y squared equals 1. And it meets up with the planes z equals x plus 6 and z equals 0. So we have to try and create what essentially would be something's not right here. What am I not seeing? Oh, good. I can see a little picture. Right, there's something still missing. What on earth is missing? Oh, I've combined two questions. That is what's missing. I'm doing my scan thing again. Question 9 has our vector field x squared, xy, z. What on earth is going on here? I have no idea what I just did there, but evidently I accidentally opened another window and was looking at divergence questions. Go figure. Right, let's return back to where I should be. And okay, now we're in the right place. Little hiccup there. Oh, we've done, yeah, question 10 is another one of those planes meeting the first octant, so I'm not actually going to do that one. Right, let's do 11. Our vector field is 6y, xz, x plus y, and we are looking at C, and it's where z equals y plus 6, which is a plane, meets up with the circle x squared plus y squared equals 1. So what on earth does the combination of those two things look like when you hit the floor, right? That's our big problem. Okay. Now, I know what x squared plus y squared equals 1 looks like. Would you agree that's just a classic standard circle? And radius is 1. Now, what happens when this plane hits that? Well, if you imagine a cylinder, which is that guy, if you imagine it getting cut by a plane, if you look down at it vertically, don't you still get the same circle? Now, if you looked at it side on, that would be different. Wouldn't you get an ellipse shape? But that guy then is the only guy that matters. Him. Now, I'm going to do it as polar, 0 to 1 and 0 to 2 pi, because this region is D. So I got that guy. Now, I also need that guy, don't I? Well, that guy is here. You see, that was kind of hidden, right? The information was given in a way that wasn't quite sure what does D look like, right? What does the 2D region on the floor look like? And what is the surface going to be? And the surface that we're talking about is the sloping plane y plus 6. Well, that should come out nice because there's a lot of bits and pieces that should disappear. So this guy will be the integral from theta equals 0 to 2 pi and r equals 0 to 1. And negative, I'll better put the letters in to keep track of everybody. That's P, that's Q, and that's R. So it's going to be negative 6y times the derivative of this guy with respect to 0, x, which is 0. Take away Q, which is xz, times the derivative with respect to y, which in this case is 1, plus an r. In this case, the r is x plus y, and I'll just call it dA right now, although I know it is going to be dr. We got a 0, we got a 2 pi, we have an r equals 0 to r equals 1. That's nothing. That's take away xz, so that's going to be take away xz plus, is that x add y? X add y. And now I'll do the r dr d theta. It looks like I get a negative xy, a negative 6x, an x and a y, and I'm going to do an r dr d theta. And anything obviously missing? Nah. Would you agree all these x's and y's just turn into r sine thetas and r cos thetas? So aren't we just going to have a horrible integral with r's and thetas in it? But it is doable. So, dot, 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 dot. If you can find the region D, and therefore the limits of integration, if you can find out who z equals g of xy is, aren't you basically plug and chug from that point onwards? Pretty ugly plug and chugs, but still plug and still chug. And I have no idea how I managed to get the divergence stuff on, so go figure. To 12. What we got? We got a vector field, negative yx squared, xy squared, e to the xy, and C, right, the curve C, is the circle in the xy plane with a radius of 6. Oh, that one is so simple, it's distracting. Didn't they basically tell me D by handing it to me on a plate? I didn't even. Well, that is good, because I'm going to do polar. So I need to find this guy. Any suggestions? I can see it in front of me.
X squared plus y squared equals 6.
Well, almost. X squared plus y squared. It's basically, it's a plane on the floor. And so the Z is just the same as that. It's very, I don't know, it's kind of awkward looking.
So
I don't
can't we
know.
can't we just call that Z equals R squared? Because
Oh yeah, definitely.
Polar anyways.
Anytime you see a Z, interesting thing is that in this question, there are no Zs. You see that? There is no Zs. But back to finishing this question off. Is going to be from, I'll do theta first for no reason, except I want to. And it's going to be negative of this guy, so that's P, there's Q, and there's R. So that's going to get me positive yx squared times, where is it? This guy, 2x. And then I'm going to do negative this guy times 2y plus R, which is, lost it. Oh, it's here. X squared plus y squared. I know I'm going to turn into R squared. You're right. In this case here, I'll just call it dA for the time being. So it's going to be 0 to 2 pi, 0 to 6. And that looks like 2x cubed y, take away 2x y cubed. Are they
Isn't
both?
R e to the xy?
Correct. And so it's going to go R dr d theta. I was hoping that was a plus. Wouldn't that be much nicer if that had been a plus? So I'm just doing a look in case it is a plus. No. It's not, it's not. I'm going to stop at this point. Would you agree that's just going to be an ugly R in cos and sines, and that's going to be an ugly R in cos and sines, and that guy is going to be really weird. Right? When you bring in the R and you do the XY, you're going to get that. That's the one you're going to have fun integrating.
It's okay, Mr. Robertson. I'm really weird too.
Okay. How are you going to do that one? How are you going to integrate R, e to the R squared, sine theta, cosine theta, dr?
Looks like it'll be a U substitution.
It will. And won't this ugly thing be your U?
Yeah, so it's pretty nice that we have that R out front to yank from.
Right. It's still not going to be pretty, but can I say dot, dot, dot and call it good?
So I've noticed that in a lot of these where you have the RD thetas, they work out where you can do a U substitution with that R that you get out front.
Mm-hmm.
Is there a reason that happens, or is it just the book sets up questions that way? Or does that
I suspect they set up
in the
because
world?
yeah. If I just randomly picked a vector function, right? I just put whatever I felt like here. And I randomly picked a C that would drop to the floor. There's a very, very good chance that the integral that I end up generating would be impossible to do algebraically, right? It would just have weird stuff like, you know, an x e to the x cubed in it, right? Something that we couldn't integrate. So these questions, I'm pretty sure, are designed to make things like that happen, to make them doable to the end. Now, what I guess you might ask then is, well, what happens if you get a real life situation where the integrals come out ridiculously ugly and can't be done exactly? Well, that's what computers are for. I mean, you just plug them into a computer program and it'll figure it out for you.
So you're saying these have been manufactured so that they work out correctly and as numbers
Yes.
that
And even saying that, I think Tessa says one of my earlier questions ends up being a bit nicer than I thought it would be. But unless I've made lots of mistakes, haven't most of these ones just end up being downright ugly, but doable? So downright ugly and doable is possible for them. I think very nice and doable is much harder to create. There are just too many moving parts. Don't you have this guy up here? Isn't that going to make your integral weird or ugly? Isn't this region going to have to behave well with the information that's here? And then on top of that, doesn't this have to work with these two as well? Now, when you've got three moving parts, can you imagine how hard it is to make them play well together so that the final integral is actually quite nice looking? Unless you go silly, you know, make that X, Y, and Z, right? If you go really, really simple, I guess you could do it. But then that wouldn't really be a good idea in the long term, because then you would think that force functions should just be simple things, and they're not. This is a good point for me to say we are finished. And I always get disappointed, and I always end up doing this same sentence. Shouldn't we have finished on a really spectacular, cool question where the answer was pi? Or at least something to leave you thinking, oh, I'd like to do more. And instead, we've left with a really ugly integral with a u sub that doesn't even come out pretty.